Okay, so just a very quick video yesterday to recap what we looked at yesterday and just to add a few new bits of information. So, yesterday we learned that all of the angles in a triangle add up to 180. That's always the rule. So if I have to find this missing angle here, I have to think my whole is 180. Two of the parts I know. So I know one bit's 80, one bit's 70, and this bit I do not know. So to work out this missing bit, I need to work out how big this bit is, and take it away just to leave that bit. So 80 adds 70, well, I know that 8 adds 7 is 15, so 80 adds 70 is 150. So now, to find x, I need to get rid of this bit. To be left with this part of the bar of the chocolate, I need to eat this part of the bar of chocolate. So 180, take away 150, and make sure you're careful when you do your column subtraction. 0 take away 0 is 0, 8 take away 5 is 3, 1 take away 1 is 0. My missing angle is 30 degrees. Now, that is fairly simple, because now we get into something a bit more complicated. Because we are maths experts, we are angle experts, we are triangle experts. And we need to know the different types of triangle, because that will help us. So, the first one is, and for some reason it's squashed a little bit, this triangle. Now, these lines mean that the lines are the same length. So this line, and this line are the same length. In this triangle, this line and this line are the same length. In this triangle, we haven't got any of those mini lines, so none of the lines are the same length. In this triangle, 2 of the lines are the same length. In this triangle, none of the lines are the same length. And we know that this little square means right angle. So, do my neatest handwriting here. Our first one here, all the lines are the same, which means that all of the angles are the same, and incidentally they're 60 degrees. Important number to know. That's called an equilateral triangle. Think about equal. All sides are equal in an equilateral. Okay. In this one, 2 sides are the same. We've got 2 sides that are same and one other side. In that triangle, these 2 angles here at the bottom, at the end of the lines that are the same, will be the same. So they are always the same. This one at the top is usually different. Because if that's the same as the bottom 2, it's not an isosceles triangle. So that is called, and I've just said it, an isosceles triangle. That comes from the start of the word iso, which means the same. And here we have an angle where we have a triangle where none of the sides are the same. That is called a scalene triangle. Now, I've added these 2 here because you might have heard them before. These are triangles with right angles in. We call them right-angled triangles. Now, they can be isosceles, like this one is, because it's got 2 equal sides, or they can be scalene, like this one, because they have no equal sides, but it does have a right angle. They can never be equilateral, because the angles in an equilateral triangle are always 60. It's a law. So, what if we're finding a missing angle? We're finding angle x. So I need to think about what I know. I know it's an isosceles triangle because these 2 sides are the same. That means that the angles at the end of the long lines are also the same. So if this one's 32, then this one must be 32. Let's add it in. And that makes things easier. So I know that in a triangle, all the angles add up to 180. That's the same no matter what type of the triangle is. I know that 2 of my angles are 32 degrees. And I know that I have another angle there. Okay, this isn't drawn to scale, by the way, so the angles might look a bit different to what they actually are. So, let's find out the bit I need to chop off. 32 add 32, which is and I'll do it as a column because that's a wise thing to check. 2 add 2 is 4, 3 and 3 is 6. So that's 64. So I need to do 180, take away 64. Find the missing angle. I'm going to borrow. So 10 take away 4 is 6, 7 take away 6 is 1. And I've got 1. So that angle is, x is 116 degrees. But what about if we have it this way? I know that the top angle is 27, but I know that this angle is x. So look at the long sides. The angles at the bottom of the long sides need to be the same. So if this angle is x, this angle is x. So we need to think of this one a bit differently. So I've got 180 degrees. I know that one of my angles is 27, and I know that the other two are x. So, but I know that both the x's are the same. So what I need to do is find out how big two lots are by taking away this bit, by taking away 77, so I'm left with this, and then, because these are both the same, dividing the answer by 2. So I've got 180, take away 27, I'm going to borrow, 10 take away 7 is 3, 7 take away 2 is 5, and have 153, which is not the answer. 153 is the same as this one and this one added up together. So now I have to divide it by 2. So I have 153 divided by 2. 2 into 1 won't go, so I borrow it over. 2 into 15, 2 divided by 15 is 7, remainder 1. 2 into 13 is 6, remainder 1. Let's do it as a fraction. So instead of saying remainder 1, we could say 1/2. Oh, 1, 2. 1/2. So it's 76 and 1/2. So x is 76.5. If I add them all together, I will get the right answer. Here we have 30. We know 30, we don't know x. Look at the straight lines. Angle at the bottom is always the same. So I know that x and x are the same. Total is 180. Two parts are both x and they're the same. The other part is 30. So we need to eat this part of the chocolate bar to be left with this bit. So 180 take away 30 is 150. That leaves me with this part. So I've got two lots of 150. I need to find one part. Let's divide it by 2. 150 divided by 2. 2 doesn't go into 1. 15 divided by 2 is 7, remainder 1. 10 divided by 2 is 5. X is 75 degrees. Ba, ba, la, ba, 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 ba. Good luck. Enjoy your challenges.